We're given the function f of x is equal to 4x over x squared plus 1. Find the derivative here. We have to use a quotient rule. So take the derivative of 4x is 4 times the bottom minus the derivative of the bottom is 2x times the top all over the bottom squared. So that's going to simplify to negative 4x squared plus 4. And then now we want to find the critical points, so we're going to set this equal to 0. And notice that x squared is always going to be greater than or equal to 0, which means x squared plus 1 is always greater than or equal to 1. And so x squared plus 1 squared is also going to be greater than or equal to 1. So it's never going to be 0. That means we can multiply it over to the right side and get negative 4x squared plus 4 is equal to 0. Divide both sides by negative 4. Add 1. You get x squared is 1, which means x is plus or minus 1. So these are going to be our critical points. And then when we evaluate them, plug it into the original function. X equals negative 1 gives us negative 2. X equals 1 gives us 2. And so these are, the critical points are where the derivative is equal to 0. So it's just going to be looking like a flat line like this. The slope is 0. And then the y value is just going to be negative 2 and 2. So these are the horizontal tangents. Now at x equals 0, we could just plug in x equals 0 here to get to the slope. So f prime of 0 is 4. And then f of 0 is 0. So the y-intercept, this is the y-intercept, that's going to be 0. This is the slope, so you just use y equals mx plus b. B is 0, that's the y-intercept, m is 4. So that's why we get tangent line y equals 4x. Okay, now let's take the second derivative. For that, we have to use the quotient rule again. So take the derivative of the top, negative 8x, times the bottom, minus the derivative of the bottom, which is 4x times x squared plus 1, times the top, all over the bottom squared. Notice that they have, each term has a x squared plus 1 factor. Pull that out. I'm left with negative 8x times another factor of x squared plus 1, minus 4x times negative 4x squared plus 4. And this one is going to cancel with the bottom, and it's going to be 3. And then I'm just going to distribute these. Negative 8x cubed minus 8x, plus 16x cubed minus 16x. And so the top is going to simplify. Well, 16x cubed minus 8x cubed is 8x cubed. Negative 8x minus 16x is negative 24x. So that's going to be my second derivative. And it's probably better just to factor it out. Easier to work with. You can factor out at 8x. And so I can set this equal to 0. Note the bottom is never equal to 0. Similar argument we made previously with the first derivative. So you're just going to set 8x and x squared minus 3 equal to 0, which means 8x is 0, x squared minus 3 is 0, and that's where we get x is 0 and x is plus or minus root 3. Okay, so now we can draw the number line, first and second derivative. So we had negative 1 and 1 for the first derivative, negative root 3, 0, root 3. And basically pick a number here, let's say negative 2. The bottom is always going to be positive, so really just worry about the top. So the top's going to be negative. Pick a number here, say 0. Top is positive, bottom's positive. And then pick another number 2, plug it into the derivative. Get negative over positive is negative. Function is decreasing, increasing, decreasing. And now for the second derivative, we know that the bottom is also going to be positive. So worry about the top. Let's pick, let's say, negative 2. 8 times negative 2 is negative 16. And then negative 2 squared minus 3 is positive. Negative times a positive is negative. let's say we pick -1. We have -8 times -2, that's positive. And then plug in 1, we have 8 times -2, that's negative. And then let's say pick 2. Okay, that's all positive. So second derivative being negative means concave down, concave up, concave down, concave up. So now we can look at the graph. So at x equals -1, so let's see from the left here, we're decreasing all the way up to -1. And at -1, we have a minimum. And then we're increasing all the way up to +1. And then decreasing again. So that's what this top is saying. And over here, we're concave down up to -√3. So it's down. At -√3, we switch to concave up. And then at 0, we go back down to concave down. So over here, it's concave down. Then we reach that as concave up. 0, point of inflection is concave down. And then at √3, starts to be concave up. So this is our graph.